Now I welcome again the Dutch Data Do to the Power BI Talks. Thank you for your visit again today to talk about this important topic we call data modeling. And I know many people are struggling with this or are new to this concept. Jay, when you are ready, if you want to share, if you have an introduction.
Yep, I will share. So yeah, thanks for having me again on this. And by the way, the Miguel session on designing reports, I can tell you, that's going to be awesome. You want to be there because he's a wizard, magician when it comes to designing reports with Power BI. It's crazy the things that he does. I didn't know our tool could do that.
Right.
And that's just it's very cool. So yeah, I would definitely encourage you to watch that and join in live. So we're going to talk about data modeling today. I'm not going to fill the whole session with slides. I can if we really need to, but ideally we would like to have a discussion on this topic. Just as a quick introduction of myself, so we have that out of the way. You might know me as a PM. I'm a program manager on the Power BI team. I own the data modeling and DAX space, so anything that has to do with building a good data model and working with the programming language that everybody loves to hate, the DAX programming language. That's my responsibility. I take it as my personal assignment to try to make DAX easier. And so we know DAX is not easy. DAX is really powerful, but it's not easy. I mean, yes, of course, in the basics, it's easy. Like doing a calculation of sales minus cost, that's the profit. I mean, everybody can do that. And then it almost looks like Excel formulas. But once you get into calculate, once you get into like filter context and row context and context transition, that's where it really starts hurting. So I see it as my personal goal to make DAX easier. So, and also the good news is we now have an engineering team specifically with the goal of making DAX easier. So we're going to improve DAX, not taking away anything away from its power, but just making it easier in use. But that's not the topic for today because we've been thinking about this. We've been working on this for a long time now, but there's nothing to announce yet. So we'll get there. Stay tuned, but not today. You also might know me from the blog. If you watch the monthly blog series, you see my ugly mug on that as well every month. I'm also very active on social media. So here's my contact details. Please find me. If you have anything that we can do from the Power BI team to help or answer questions, even if it's not data modeling or DAX related, I'm happy to relay it to people that are not on social media or not as active. And we're here to help. We're here to make sure that you succeed with Power BI. So the topic for today is data modeling. And that's a very, very important topic because almost no day goes by that I am involved in a customer case where the customer ended up with a badly performing Power BI report or a Power BI report that doesn't return the results they wanted. And it can be traced back to the fact that they didn't build a good data model. And some people say like, hey, why don't you as a Power BI tool force people to build a data model, a good data model? We'll talk about what a good data model is. But also part of the beauty and I think part of the success of Power BI has actually been you can throw in any data, even a flat table, and you can just get started. The problem is that at some point you will start doing more advanced stuff. For example, when you get into the DAX area, where you start building DAX formulas and measures, and that actually makes assumptions about the data model that you have. And that's where if you have a flat table and we make assumptions you have a different data model, things start breaking. So that's why I think it's very important for more people to understand the importance of data modeling when it comes to using Power BI to its fullest, and what that then means. What that does that mean? So that's where I wanted to talk about today and have a discussion about. So really, when I think about the process that people follow when building a report, you start with gathering data. You start with after you know where the data is, you start cleaning it using Power Query. And then everybody wants to jump to visualizing, building charts, which is great. But there's this middle, the third step that some people even skip. And actually, if you want to be very successful and get all of the power out of Power BI that you can get, you shouldn't skip the model step. it actually makes or break your Power BI report. It will give you better performance, better usability. You can use all the advanced features of Power BI if you have a good data model. Now, what that means is a data model is actually just a set of tables and relationships in a certain order, right? When you load data, you'll get separate tables. You get tables, they are clean, nice, but there's no relationships between them. Also, what we talk about when we say data modeling, we also think about measures or other things that you can add on top once the tables are loaded or connected in Power BI that will add value to what you loaded. So, let's talk about like data modeling basics, right? So a data model is really a collection of tables with relationships that enable business users to easily understand and explore the data. Why is this important? Well, it's not only that the performance will be better, but it's just, it makes life easier for people that, for example, don't know a lot about like the technical workings of Power BI, but just need to drag and drop a visualization to the canvas. If you build a good data model, it makes them easier for them to understand. So a data model is nothing more than, in the basics form, tables that you loaded, relationships between them. And of course, you can then add stuff on top of that, but that's the basic form of a data model. That's what we mean when we say you need to do data modeling. You need to do this. Now, a good data model for Power BI is not any data model. Power BI is really built around the idea that you have a dimensional data model. And a dimensional data model is not a flat table. Your Excel sheet with just one table with all of the data in all the rows is not a dimensional model. That's a flat table. It's a different data model. It's still a data model because it's one table. So technically it's a data model, but it's not a dimensional model. So it's not a good data model for Power BI. The other very popular data model that you see everywhere is what we call an OLTP model, or an nth normal form model, like a fifth normal form model, which is under transaction systems like your ERP system or your CRM system or your help desk system where you log tickets. Those will almost always log them in a relational database in a OLTP schema. That is another form of a data model, not a good one for Power BI. What we really want you to do, if you want to get the best out of Power BI, you need to build a dimensional data model, also called an OLAP schema. So OLTP versus OLAP. Online transaction processing, T, versus online analytical processing. And you can immediately already see why analytical makes sense, because that's what Power BI is. It's an analytical tool. It's not a transaction processing tool. It's an analytical tool. Then Power BI assumes you have a dimensional model. And with those assumptions in mind, we can do optimizations on DAX. We can do advanced features like, for example, the field parameters that just came out in preview a couple of days ago. They all assume you have some kind of dimensional model. So you can already see if you push forward with an OLTP schema or you push forward with a flat table, those features will make the wrong assumptions. They assume you have a dimensional model. You don't, and then you end up in trouble. So, as I said in the beginning, many times the issue is the fact that you don't have a good data model. And that data model doesn't help you in the sense that it doesn't help you to build the beautiful reports faster. It just makes for faster and easier to use reports. So invest in it in the beginning instead of having to redo everything afterwards. So resist the temptation to just go from cleaning data immediately to visualizing stuff because your customer or your manager is shouting and say, I want the results now. Resist the temptation, build a good data model, and that will go way longer than just sprinting towards the goal. This is a marathon. It's not a sprint. And the marathon is in preparing and building a good data model. So when we say a dimensional model, we mean fact tables, we mean dimension tables, we mean relationships. So just to clarify a little bit, I won't go into too many details, but basically simplifying things, a fact table is anything you can count. Like a fact is just a list of numbers. 5 is a fact. It doesn't tell you anything, because if I say to you 5, you don't know what. Am I talking about 5 houses? 5 cars, 5 cows, 5 people? Who knows? The extra questions that you make, that you put, like, what are you talking about with that 5? And that's the dimensional data. So you would ask, okay, 5. 5 what? Well, we've sold 5 products. Ah, product is a dimension. Okay, we sold 5 products. When did we sell it? Hey, another dimension, date and time. To whom did we sell it? Oh, to a customer, another dimension. Where did we sell it? Well, we sold it in this store. Hey, another dimension. How did they pay for it? Well, they paid using cash. Hey, that's payment type, another dimension. Right? So how now you can see by asking those questions, you get from this number of 5 to all of these dimensions that add context to it. And that's your dimensional model. The fact table in the middle and all the context around it. So those dimensional models are also often called star schemas. Because why? They look like a star. Put the fact in the middle, the dimension around it, squint a little, you might see a star. And if you build multiple fact tables, you have a snowflake, or a galaxy schema, as they're called now. So that's basically the basics of what a dimensional model is. And Power BI, I cannot stress that enough. Power BI assumes you have a dimensional model. 95% of the performance issues or the issues with DAX that people face today, because DAX is either hard to write or doesn't return the right results that you expected, are able to be traced back to the fact that you didn't build a dimensional model. Build a dimensional model, your DAX will be way easier to write, will work way better, will give you the good results. So good dimensional model, easier DAX. Bad dimensional model, complex, very badly performing DAX. That GIF, well, I don't know. What should I say? I don't think anything I'll say now will make that situation better. So I won't just won't comment on that one. So does this help as an introduction? Anybody that wants to jump in here at this point? Any reactions? Is this new to you? Any questions about this topic so far?
You can unmute or use the chat for the questions. How many of you are new to this concept, to the design? I know that for some, sometimes this is new. Don't be shy.
Has anybody built a dimensional model before? Can you raise your hand? It's the backbone of the whole product. That's true. So how did you learn that, Fernando?
Well, in my background is finance and accounting. I changed careers, but I started already 5 years ago or more learning, but slowly. And I'm just reading the star schema from Christopher Adamson now. It's too late, but no, not better late than never. And then I just didn't know exactly what a surrogate key meant. And I was confused with the transactional models because I was used to work with SAP, for example.
Yes.
And then they have this table for the orders header and another table for orders details. Yep. And then I just was knocking my head on the wall, trying to understand the difference of this analytics model, which is so important.
Yes. So the SAP you mentioned is an example of an OLTP system. And it makes sense because those systems are built for something different than answering OLAP questions. They are built for speed, for handling massive amounts of queries, but massive amounts of very small queries, like update Fernando's address. That's a very small query. Like those, like huge volume, low complexity. On the analytical side, the type of questions that people ask with Power BI is not what is Fernando's address. We're not interested in that. What we're interested in is what's the average number of products that people with the name Fernando all across the world bought, and which products were that, which product categories were that, right? That is an analytical question, but that's a very complex question. And a tool like Power BI will fire very complicated questions, but less volume of them to the database. And that's why that database cannot do both. And that's why you should never run Power BI on an OLTP database. And you should never have the same database host an OLTP and an OLAP model, an analytical model, like a dimensional model, because that thing cannot do two things at once. It's like the one I really like is the tea party analogy, right? If you're in a tea party, imagine everybody sitting in a circle, right? And then two ladies or two people that are sitting next to you on either side start chatting with each other a lot. And you are trying to focus on the people on the other side of the circle to try to have a conversation with them. How do you think that will work? It will not, because there's huge volume here of chit chat going on, and you're trying to focus on this deep discussion on the other side of the circle. You will not be able to follow that. And that's exactly what a database is struggling with when Power BI comes along while it's busy doing transactions, like transaction processing stuff from an entry system, to try to analyze and answer an analytical query. That analytical query will never be answered, or will be very slowly be answered. That's why you need to have it split out in a different data model. That's step one, and then have the data model on a different system, or sometimes even completely different software. Like, for example, SQL Server is great at answering OLTP questions. It is okay at answering OLAP questions, but SSAS, or analysis services, Azure Analysis Services, it's great at answering OLAP questions. You should not use analysis services to answer OLTP questions, because it will not work. So, that's kind of the different types. I also like the book, The Data Warehousing Toolkit. I think that's the original from Kimball from 1970 something, I think, which is really old, but that's like my standard go-to. But I also like the Schema Complete Reference one by Christopher Adams, and that's also a good one. But I like the really old one. I still have a copy of it somewhere. It's really outdated, but the basic idea of a dimensional model, that one, yes, exactly, that one is really like, that's the standard. That's almost a Bible for.
It's the Bible.
It's the Bible for dimensional modeling. It's outdated though, like the technical examples they give, yeah, but yeah. Anyway, cool. Thanks, Fernando. Anybody else that wants to jump in here?
Hi, I'd like to know, in OLTP to OLAP, do you mean to combine the relevant entities together? Let's say customer. In OLTP, there are like 10 customer tables, for example.
Mm-hmm.
So if you try to even make it dimensional, there's like a lot of effort first to bring all the customer to that customer entity,
Yes.
And then kind of create that dimensional model.
But that's exactly what you need to do.
Oh, okay.
So you have 10 customer tables, probably because they are different types of customers. You might have a customer table for corporate customers and a customer table for personal customers, right? For example, I'm just coming up with an example. I would, we would, in a dimensional model, what you would do is you would bring those corporate customers and ideally move them into a customer dimension together with the personal customers, and then have a customer type on there that says, hey, is Cecilia a personal or a corporate customer, right? And then anything you share, because you will see between the corporate and personal customers, many times you'll share the same information, like an address, a phone number, email address. That's the same for corporate versus personal. Sometimes for corporate, you have something else, because there might be a relationship actually between corporate and personal, where there's like a spokesperson or contact person for this company. So that is actually how these two tables then can interrelate, but that's already pretty complicated. But in general, yes, you would move away from the OLTP schema, which is built for making sure no data gets duplicated, none at all, to actually an OLAP schema where data duplication is fine. For example, if you have multiple customers living in Miami, in an OLTP schema, what you would do is you would say, hey, I have Cecilia and Jay, they both live in Miami. I don't, but let's just take that as an example. I would add a table that has customer city as a name. I would add Miami as an entry, and then we would each get a numerical reference to Miami, right? So let's say Miami is city number 1, so each of us gets number 1. That is data deduplication, because Miami is only stored once in the database, we just refer to it twice. That's actually the wrong approach for OLAP systems. For OLAP systems, it's better, in general, to have Miami just stored as duplicate items, although it's not optimized, right? It's still storing data duplicate, but it's more expensive for an OLAP database to traverse the relationship to another table than just look through the duplicate items, because it can optimize on the duplicate items. So you would basically, what you will see is you will go from a 500 table schema to maybe a 100 table schema, because you start combining entities into bigger ones. And this is not easy. This is not like you cannot just go and say, hey, run this tool and I will have a great dimensional schema. This is actually the core business of many business intelligence consultants, is actually building a good dimensional model. It's almost like an art or magic instead of a science. Yeah, so it's tough, but it has to be done if you want to be successful with Power BI.
And in case if that was just an example of customer, let's say, you know, the example is more, you know, OLTP is more, I would say, snowflake schema, right? Where there are like multiple tables, you know, joined with each other. So is it good to, you know, combine those tables? As you said, maybe the data is duplicate. It's not a problem, but try to combine as many, or try to combine a table in a way to create like a dimensional model, so we have lesser join and for performance reason, right?
Yes, you would want to reduce the number of hops that the system will have to take from one table to the other. OLTP systems love hops. They hate data duplication. So you would always split out tables. That's why you call it the 5th normal form. If you look that up, it's actually the way to build many small tables. So there's no data duplication, but there's many hops that it needs to take to another table, which is something an OLTP system is great at. OLAP systems don't like that. You would actually do the reverse. So the first time as an OLTP database, when you, as an OLTP database designer, you see the request to build an OLAP schema. And I can remember that day from years ago when I was still a student, before I even worked at Microsoft. I worked at a company that was building business intelligence systems. I came from university knowing everything about 3rd and 5th normal form. I never did build a dimensional model in my life. I looked at it, like the dimensional model that they were building, and I went like, that's not a good database, because it's data duplication everywhere. It's like, you should build this as a 5th normal form. And what they said, they knew I was wrong, but they let me fail. They said, okay, fine. Take our reporting tools, transform our model that is with duplication, make a 5th normal form model out of that, basically do the reverse, bring it back to OLAP, OLTP, run the same reports on it, and see who wins. Well, of course, my OLTP, the thing that I thought was the optimal, was of course horrible, because I didn't know that the queries it runs and it's good at answering are not the queries that you need to build an analytical report. Those are just two very different things. So it's a magic. It's not a science. It's an art almost to come up with a good dimensional model, and it takes a lot of time. But the one way of doing it is literally starting with a very simple thing, like, what is the number that we want to track? Like, what is the most important thing that you want to track in your business? Is it number of customers, or number of beds that are available in a hospital, or how much money you made? So write that down. on a piece of paper, profit, circle it, and then add lines to other circles around it that goes like, how would I want to slice this number, right? I end up with 50 million in profit. That doesn't tell me anything. I want to know when. Oh, great. That's a slice. I want to know how, to whom we sold this. How did we make this money? What did we do for that? Oh, we sold a product. Oh, so then we sold a product. Hey, another thing. To whom did we sell it? How did we sell it? How did it become a customer? How did they pay for that? All of those things will then feed into a dimensional model. And those are the business processes you want to analyze. And if you don't have any idea on what those are, you cannot start to build your dimensional model. You need to start to ask your business users, like, what are you wanting to analyze? What is you hired me to build a Power BI report for you. What are the questions that you have? And they go like, well, I want to see sales over time by product, by region. Hey, number is sales, time is a dimension, product is a dimension, and region is a dimension. Great. Now you know at least something. And that's how you slowly grow your dimensional model. Start with one fact table with a couple basics, and then expand it, expand it, expand it, expand it. So hopefully that helps.
I see some hands there. Any questions? Nax, I see your hand is raised.
No, I'm good, actually. Thank you.
Okay. It's actually fun doing this. Once you start doing it, analyzing, and it's like, I don't know. I have fun, at least. I don't know if that's too nerd from me.
Yeah, well, it's a fun process. I love it. It's almost creative, and trying to put together something that people can work with, that can answer the business question. It's a very interesting puzzle to play with. So let's see, just to hammer home that point. I think this is actually comparing those kind of stars, the things that we talked about so far. Flat tables versus normalized, which is an OLTP schema, versus star schema and Snowflake, which are both types of OLAP schema. You can also add Galaxy to the right of Snowflake, where Galaxy has multiple fact tables. So basically, you see the performance for analytics is very low for a flat table. For normalized, it's okay-ish, maybe, but for the others, it's definitely high. In level of development effort is again high for building a good data model for Star and Snowflake if you don't have it, and also building a good normalized data model if you don't have it is also really hard. And then query volume complexity, we talked about it. Flat tables are really built for low volume, low complexity. They cannot really handle anything. And then when you go to normalize, you have high volume versus low complexity. When you go to Star and Snowflake, you get to low volume, high complexity. Those are the type of questions that Power BI will ask to the database, right? They're intended for, well, flat tables are not intended for any database at all. Keep them in Excel, but don't try to build any data analytical things on it. It's just not going to work. CRM systems use normalized schemas, and then star schemas and snowflakes are used by analytical systems. Now, the last row here is compression. So what happens in a database system? Most databases try to optimize performance by doing something smart with memory. You might hear things like in-memory processing or data compression. Well, technically, there's two approaches. You can either compress by row or you can compress by column. So what that means is in compress by column, we look at all the values that are in the column, for example, city, and we look at every time that Miami appears. And the first time it happens, we add a number. We say, hey, Miami is number 1. And every time that Miami is then seen, we map it to that same number. Wait, didn't we just do that for a normalized table? Yes, but that's on disk. This is in memory, which is different. And that's why this is actually how the analysis services engine works. It does this compression in memory by looking at all the values. So imagine now the analysis services engine trying to do that with your normalized schema. Wait, in a normalized schema, there's never a duplicate string value. Miami only appears once. So can it do any optimization? No, it can't, because there's nothing to map it to. because Miami only shows up once, so it cannot make optimizations on it. And that's why Power BI doesn't like a normalized schema, because it cannot do any optimization. It will just go as slow as it has to be. And I don't want to go into all the technical details on hash maps and how we map this into memory and how we make that performance, but this is basically it. We expect you to have data duplication. We expect you to have a star snowflake. Comments, remarks, questions?
Come on, guys.
And girls, and anybody else.
This is a very good comparison. I like this chart.
Thank you.
I've seen people that don't know how to do data model, or maybe they don't know about it, right? The star schema. I've seen people doing a table of the table of the table just because they cannot come up with the logic to create some formula, right? So that happens. I mean, not
Yes.
to blame the person, because if you don't know about this, I mean, it's normal. It's like you would try to work out your way. But imagine like even tables by year, a table for 1 year, a table for another year,
Yes.
and like that, right? And that is
Yeah.
because of this. And it makes the DAX so complicated.
It makes DAX horrible, and the performance is horrible. Power BI will not know what to do. And yes, somebody at that point, when you create multiple fact tables for years, will have to tell you, but wait, isn't year just a context to the fact? Does the fact, one easy way to spot this is to look at those different tables and look at if they have the same structure. And if they have exactly the same structure, there's chances, big chance, you can actually mesh them into one big table.
Mm-hmm.
And with the same structure, I mean the same columns and the same data types in each column, right? So for a fact table for sales in 2018, you'll have a day, you will have a product number, you have a customer number, you have a sales amount, you have a tax amount. That same structure will happen for 2019 and for 2020. The data in it will be different, but the structure will be the same. That should be a hint to you to go like, wait, that should actually be mushed together. And then everything that is unique about each of those roles that give me context, like the date, like the product, like the customer, should go into a separate table. Like a context data is almost always textual, and the numbers, the things you want to calculate on, the averages you want to do, the sums, the min, max, whatever, those stay in the fact.
Maybe we can add, but no, you guys from Microsoft can add some kind of welcome message inside the Power BI, say, I don't know, with a link to data modeling.
Well, I mean, we've considered that, but part of the success of Power BI,
splash screen, you know, like the welcoming screen.
part of the success of Power BI is, of course, that anybody can just jump in with anything. I mean, Power BI will not work on smaller data sets, right? If you're just dabbling in it and just trying something with an Excel sheet or just loading a smaller data set, it will work. I'm just talking about professional level, like actual getting most of it out of Power BI. So the problem is we cannot stop you from doing this from the beginning, because that would also just put up roadblocks for you to adopt Power BI. And to be honest, the fact that it's so easy to start with is also a great reason why it's so popular.
Yeah.
So, but that doesn't mean that we could, and we're thinking about doing things like, hey, we notice, right? We notice you have certain patterns in DAX that you build. Hey, we notice you have built a certain form of how you set up your data model. Here's some best practices, right? There's a best practices analyzer, by the way, that you can run as part of Tabular Editor that has rules for data modeling by my colleague Michael on the CAT team. You can run those rules against your data model. And we're thinking about making that core part of the product so that we could say at some point, hey, we notice Power BI performing less, or the DAX queries become really hard or really complicated. We see that, the results are returning very slow. Here's some ideas on how to improve your data model. And that's what we can do. And we could even potentially take a step further and say, let us propose a data model for you. I'm not saying that's going to be a foolproof solution, because it's not, it's an art. It's not a science, it's not an algorithm you can run, but we can do something based on heuristics to propose a good data model for you.
But actually, there is something already implemented, right? The auto time intelligence that is there.
Yeah,
That's
exactly.
Something. I'm not sure how many of you are new or beginners in Power BI, but maybe you noticed the first time that you used it, when you have a date time or a date column, it will show up with a different icon that provides you with a hierarchy, right? What's happening? Tell us what's happening behind the scene, Jay, with that, and why we don't want it, maybe, right?
I will look it up. Just a sec. I have it in this deck. Let's see. Yeah, so here we go. Auto date time. Look at that. I was prepared. Well, to be honest, I've got 100 slides in this deck. So any data modeling question you ask, I probably have an answer to in the deck. But anyway, so auto date time is great under certain circumstances. So what happens is, in order to help you do date type calculations like year to date or month to date, very common calculations like what's our sales month to date, what is our sales year over year. Those are very common calculations that people want to do. To make them performant and make them easier, you need a date table. Now, if you start from a data warehouse, you already get a date table. Now, for people that don't have that, because you started with a flat table or you don't have the date table, we will, as part of Power BI, if you don't disable this feature, we'll create that date table for you. You won't see it, it will be hidden, but it will be there. And why? Because we need it to have, for example, total year to date, which is a DAX calculation function, will not work if you don't have a date table. And if you don't have one, we'll create one for you. Now, important to remember is that it creates a date table for each date in your model that is used in a relationship. So let's say you have a sales fact table, and you have, on that sales table, you have an order date and a shipping date. So you have two dates. If you relate those two, if you want to use those to analyze your for example, your sales year to date by shipping date or by order date, we will create two separate tables for you, because there's two dates here, not one, two. So you can imagine that's actually not very optimal, because your data warehouse would have had one date table and would have just reused that same date table over and over and over again. This auto date time thing creates a date table per date. So if you have 50 dates, it will create 50 date tables. And that is also what the slide says. It will bloat your model, right? Your model size will grow huge. So my advice, if you don't have a date table, create one. There's multiple ways of doing that. There's like PQ statements, Power Query statements. There's even a DAX statement, calendar auto, that you can just do as a calculator table. It will create a date table for you. And then disable auto date time, and that way use that explicit date table, as we call it, not an implicit date table, not the auto one, the explicit one, to use to optimize the performance of your data model. Auto date time is great if you don't know what you're doing, and with a small data model, it's awesome. But very quickly, once you have more than one date, it will start hurting you, because it will add date tables and date tables and date tables, and before you know it, you end up with 50 date tables. So please consider doing that. Look at that. I had an answer.
You have a question from Javier.
Let's see. I'm looking at it. Any rule of thumb when it would be okay with Snowflake, and whether to go with many-to-many to avoid snowflaking and stick to your star? Yes. go with Snowflake model, not go with Snowflake the product, by the way. Just be clear. Go with Snowflake model. I would try to avoid many-to-many as much as I can. Personally, I would always build a Snowflake and avoid my many-to-manys. That's just my take on it.
For those who are new, what is many-to-many?
That's a good one. Let's see. We need to talk about relationship types. I'll scroll in my slide deck again, because of course I have a slide about this. Of course I do. So a relationship is a connection between two tables. Usually you will see in a pure star schema, there's only relationships between a fact and a dimension. Right? So the fact is in the middle, the dimensions are connected to it. You will see keys between those two things. For example, we'll have customer key in customer ID or customer key, whatever it's called, in the dimension, which will be unique. There is only one ID for each customer. And then you will have the same customer key showing up on the fact. And if you sold a product, or sorry, if the same customer bought more than one product or placed more than one orders, hopefully you have return customers, that same ID get mapped to that table, right? So Cecilia will be customer 1, I will be customer 2. If I buy 2 products over time, I put in an order now and the next week another, you'll see my customer ID showing up twice in the fact table. But it's only one customer, it's only one of me in the list. Now, that is basically the relationship. In a pure fact, it will only be, in a pure star schema, it will only be a relationship between dimensions and facts. Now, in a Snowflake, you can also have relationships between 2 dimensions. For example, product category might be a Snowflake, and then it might be a dimension, and then product might be another dimension, and product is then related to the fact. There's no direct relationship between product category and the fact, because your business question might be to get just the sales amount for product category, like total sales amount for bikes, but it could very well be what's the total sales amount for this particular bike. So instead of then having 2 relationships to the fact, what most people do is they move the product category dimension behind the product dimension. So you can answer both questions with just one relationship down to the fact. And that's a Snowflake, because you have dimensions hanging off of other dimensions. And then when you see that, that's a Snowflake. And there's a couple like, without a relationship, there's no way to you to analyze the data, by the way. So you need to build those relationships to be able to answer how many bikes did we sell. And then there's a couple of relationships, one-to-many, which is the most common, and then one-to-one, and many-to-many. So here's examples of each. So one-to-one means there's a one-to-one mapping. So each individual record in a table A is mapped to one individual record in table B. Now, if this happens in your star schema, you should ask yourself, why is this? Like sometimes there's good reasons for it, but most of the times it's just because you were lazy and you have a table split out from your OTP schema that you actually should have joined together, right? For example, if there's a one-to-one mapping between a customer and, a product and a product category. So there is all of the products are always in one category and each category has only one product. Why is there a separate table for product category? Because it's a one-to-one relationship. Remember, the OLAP database doesn't like to make hops unnecessary. It doesn't like to traverse relationships if it can avoid it. So rather, you would put the product category into the table itself of the product. Get rid of that extra table and relationship, your one-to-one is gone, performance will be way better. Now, one-to-many basically means there's one record in table A and it's mapped to multiple records in table B. The example that I just gave is you have a sales table and you have a customer table. Your customer bought more than one order, sent in more than one orders over time. So they're a returning customer. You'll have a one-to-many relationship between the sales fact and the customer because the same customer put in multiple orders over time. So there's a one-to-many. This is by far the most common. If you see a data set that has only one-to-manys, that's actually really good. If you see the reverse, you're in trouble. And then many-to-many is the last one, in which multiple records are mapped to multiple records. So multiple records in table A are mapped to multiple records in table B. For example, students and courses, right? If you have a course on a university, hopefully for the university or for the school, there's not one student in each course, because that would be bad for business. So there will be many students in many courses, because hopefully also a student just doesn't take one course and then disappears. No, hopefully they're here for the long haul and takes more courses than one. That's a many-to-many relationship, which is not a bad one, but has performance implications. And sometimes people bridge many-to-many relationships. And what that means is you would actually add a table in the middle between student and course that would say student course, for example, that would actually capture the same information as that many-to-many, but then in 2-3 tables with 2 one-to-many relationships. That's how you create a bridge table. A bridge table is nothing more than just decomposing a many-to-many into 2 one-to-many relationships. Now, the fun story is, in the early days of Power BI, we didn't support many-to-many. We required you to build that bridge table. Guess what we do today if you build a many-to-many? Any ideas what we do internally? Hidden beneath the covers?
It's automatically. Yeah.
We built that bridge table for you automatically. Exactly. There's no magic. We just built that bridge table for you, but we won't show it to you. So that's it. Are the results wrong with multiple many-to-many relationships? No, not necessarily, because we will bridge. When you build a many-to-many, we will create a bridge table for you. So you are looking at a many-to-many, but actually it's 2 one-to-manys with a bridge table that you were just too lazy to build. We created for you. So no, they shouldn't be wrong. However, because of this not being pre-processed and not being pre-optimized, and sometimes even being created by Power BI on the fly, you can see why this performance of this might potentially be worse than you actually going to the effort of splitting this many-to-many out into 2 separate relationships and build a bridge table on your own. So that's the types of relationships that exist. Yeah, I hope that answered that question. Sure.
How about like multiple facts in case if you have a fact for sales and you have a fact for payments, right? And you have multiple dimensions, which would be using both of those. So how do you do that, in a model where there are like multiple facts?
Good question. Let's see. Do I have something about that? Yes, I do. Sorry, I just find it very funny that I have an answer to most of the things that you ask. So basically, it's very common to have a multiple fact table schema. That's now called a galaxy schema. So you graduate from a star to a snowflake, and then from a snowflake to a galaxy. I don't know why they didn't continue from star to something else to galaxy to make it like all star based. Somehow snowflake got in the middle. I don't know why. We should maybe have gone from star to snowflake to igloo or something. But no, we went to galaxy. Anyway, that's the name for it. So basically, it's very common. So there's 2 things you could do. You could either, if the fact table has the same structure, like what we refer to, for example, if it's actually capturing same information but on a different topic, for example, a different region or a different year or a different product, you should append that into one big fact table. So you should basically collapse all those multiple facts into one. That's the first scenario. That's not the most common. The other scenario is different level of granularity or completely different topics, like what you said. You have cost and you have sales, or you have sales and you have whatever, something else, expenses, right? So you have your inventory as well as your sales in one big data set. Now, the question really you should ask is that really necessary to have that in the same report? Is there value in having that in both? Sometimes you have, for example, it might be interesting to see how long is a product that you bought has been on the shelves before it was sold, right? That's a shelf lifetime. It's an interesting metric to see how successful you are in optimizing what you buy versus what you're selling. So in that case, you want to have those two. So what you do is you build what we say a mapping table. You basically build something that's very simple like this, where you basically go like, hey, for each of these topics, which dimensions are interesting? And those will then become your shared dimensions. So whenever you can put two crosses in this example, those are called shared dimensions. So here we have internet sales and reseller sales. Both are sales, but they're different types of sales. Because in reseller sales, there's a store where the customer went to. There is probably an employee who helped them. With internet sales, there is no store. There's no reseller. There's no employee that helped them. But there might be information about the customer because they made an account. But when they went to the reseller, you might not even know who you actually sold to because they just walked up to the store and took the product and went to the cashier. Right? So in this example, loads of the dimensions like currency, like when was the order placed, when was it due, what product did you sell, was there any promotion in, when was it shipped, where was it sold, those are all common or shared dimensions because they can be valid for all of these scenarios. However, some of them, marked black here, are not. And that's totally okay. So what you do is you basically you combine those two either together in one fact table. So you make internet sales and reseller sales into one big sales, and then you leave the blanks where they are. So you get something like, hey, in the type of an internet sale, the customer, or sorry, in the reseller sale, the customer is empty, right? That is fine. That's okay. That would still be considered a star or a snowflake because it's not a galaxy. You could also just leave them separate if they're really disjointed. If, for example, there's many black areas here, and there's only maybe one or two shared dimensions, then you would split them out and keep them separate and not try to join them into one big fact. This is also a little bit of art because there's no hard or fast rule. My take on it is say, if the majority of the dimensions are shared, I would put them into one big fact table. But it's all about like testing various scenarios. If it's the reverse, split them out. But what happens if it's like close to 50-50? That's of course the hard question, right? But in general, yes, you can have multiple fact tables. You would share dimensions. Your date would be shared. Your product would be shared in this example. Your sales territory would be shared in this example. But customer or employee or reseller will not be shared. It will be there, but will only be related to your reseller sales. So once you have that, if somebody clicks on reseller, all of the sales, only reseller sales are being shown, right? Internet sales doesn't slice, doesn't change. That number doesn't change because it doesn't know how to change it because there's no reseller sales relation, no relationship between reseller and internet sales. And that's where it gets interesting because you have to then educate your users like, hey, if you click on reseller, yes, the reseller number should change, but internet sales won't change because it doesn't have any relationship. I hope that helps.
Got it. So in my example, it was sales and expenses, right?
Mm-hmm.
So expenses in one fact, sales in other. And if there is a report where, a breakdown is required on a product with respect to sales as well as with respect to expenses, is there a good way to, get the data from both the fact table, or would there be like any relationship between these two, like a sales and expenses, or those would still be, remain disjointed and just,
of course, it's hard to answer right now because it really depends on how many shared dimensions you actually have. But if the example is just a product and sales and expenses, I would just split them out as two separate and then relate product to both. Because that way you can just say, hey, I'm interested in product A. Let me see all the sales and all the expenses that we made for product A. Right? You can still click on one product and have both of them filtered.
And are there like any scenarios where you need to also connect fact with fact or the fact?
Well, I say no very quickly.
Okay.
It shouldn't be, although sometimes there is. For example, if you have a sales order table, right? You will, for example, want to capture a customer put in an order for this amount on this date, right? Fine. Depending on the data volume, it might not be performant to have also the product in that same level of detail. So you might want to, what they call, aggregate this to a higher level of detail, to just store that Cecilia bought products of the value of $100 on this date. What products she bought? Probably not, like maybe for majority of your business questions, not even interesting, right? You're probably not even interested in the individual products. You just want to see how much profit you made on Cecilia, for example, right? Now, sometimes in other business questions, people want to go to that level of detail. So what you will see is that sometimes people will have two facts that actually are related. For example, you might have an order detail that doesn't have the customer on it, but does have product name on it, and then has a relationship to the sales order header or sales order table, which then has the customer name on it, right? So that way, yes, you will have a relationship between two facts. It is not very common. It happens, but there's, for example, a concept called aggregations in Power BI, in which you can actually avoid this situation and have Power BI create the aggregated table for that sales order level without the detail on the product. That is going to be way better performant for you, and for your customer, the users, they will only see one table to work with. They will just see sales order, and then depending on the level of detail they ask, are they asking for individual products, or are they just asking for totals on the sales order? Power BI will either use the detail records or the aggregated records. That way, we optimize it, you pre-aggregate it, and you don't have this relationship between the two. But yes, technically that can exist, but it's not very common.
Okay, thank you.
Sure. Somebody has a hand up. Office manager, I don't know what your name is, but go for it.
Yeah, hi. So it's related to what you're kind of talking about already with multiple fact tables. So
sure,
if you have one fact table with the detailed records, but then you have another fact table that's already pre-aggregated, and you're saying to use a shared dimension, does that work the same way if one fact table is already pre-aggregated? You just find a shared dimension to relate them?
Yes. And if you can't find them, so as like in my example with sales order versus sales order detail, that shared key is actually not nowhere, right? It's not customer, because it's only captured on the sales order. And then in that exceptional case, you will see a direct relationship between that detail and that sales order table, because the only thing how you can relate those two is by the fact that that product was sold as part of an order.
Does it have to be related though? Can you leave them, the fact tables, unrelated?
Because if you don't relate them, you cannot compare them.
Okay.
Right? So if you don't relate them, there's no way for your business user to go like, oh, I'm now looking at the total things that all of the orders of Cecilia and the total amount. Now, great, I understand that. Now I want to understand which products he bought. There's no way for that business user with that question to jump from where they are now to that next level of detail without having to set up all the relationships again, without them having to go to another visual and go like, oh, now let me add the level of detail. Let me take a list of the products that, or the order numbers that Cecilia has. Let me make a filter of those and then put them into that next visual, and that way get the level of detail. I say, yes, technically they can, but it will be a lot of work for them. It's simply solved by adding that relationship between the two facts and linking these two together. That way, that customer can then say, now I understand that we sold for $100 to Cecilia. Let me go to the next level of detail to understand which products he bought. And by that, they go to the next level of detail table. It won't hurt them because they don't know, but that's exactly what will happen. So technically, yes, of course, it will be possible, but they will have to do a lot of manual work by, for example, taking order numbers. Let's say there's 500 orders for her. They will have to take all those order numbers and put them into a filter on the new table. That's not how, that's not very useful, right? It's not very user friendly. So yes, you would have to build it. You don't have to, but for your sake, for their sake, You just build that relationship.
Okay, thank you.
Sure. Any other questions?
I don't see any. Do you have anything on the direction of the relationships?
Of course I do. Of course I do. Let's see, directions. Where are you? Relationships, types, column settings, relationship direction. There you go. So we talked about relationship types, right? So one-to-one, one-to-many, many-to-one. Now, if you ever worked with a SQL database or other relational database, you are familiar with these concepts of foreign keys and primary keys. Those are relationships, essentially. However, Power BI adds another thing on top. Not only does a relationship have what we call a cardinality, which is what this is, right? How many are on either end of the relationship? That's called the cardinality. Not only does the relationship have that, it also has a direction. And a direction is actually really about how do selections flow. So you could have two types of directions. There's a couple subtypes, but in general, singular, or bidirectional. So what does that mean? You'll see that in Power BI, if you have that line between two products, two tables, here on the left with product and sales order detail, you see there is a little one-to-many in the middle, which is the relationship type. So this is a one-to-many relationship. So there's one product on the left side, there's many products on the right side. So it basically means each product has been sold more than once. And then there's this little arrow on the right. You see that in the middle? I can probably point to it or zoom in even to make it easier. Right, there you go. Now you see the little arrow, right? That means that I can filter sales order detail by selecting products. So I can ask for example, color. We might have red and blue products, right? I select product color equals blue somehow using, for example, a chart or a slicer or index. I can then use that information to calculate the unit price or the unit price or the order quantity that is in the sales order detail table, because that arrow points from product to sales. Make sense? I cannot do the reverse. So I cannot go, let's look at modified date on the sales order detail. I want to see all of the orders that have been modified on the 1st of May of 2022, and then expect to be able to get a list of products that are included in that order. Although the relationship exists, this arrow prohibits you from what we say pushing the filter or flowing the filter to the other side. That arrow will stop you. It's like if you know something about LEDs or diodes in electronics, it will only flow, like allow electricity to flow in one direction. This is exactly it. It will stop electricity from flow to the other direction. This is exactly it. So you cannot go modify date 1st of May and then expect products to be filtered. This is one direction, haha. Sorry. The other one, which originally, by the way, was the only one that we supported, was bidirectional. Now, bidirectional is basically the same, but allows you to go both ways. So now with this type of, you see two arrows, you can go from left to right, but you can also go from right to left. So originally, this was the type that we advised people to do, but it has performance issues and it has impact on surprising results, especially if you're working with multiple fact tables. You can get very bad performance and ambiguity, and I think I have a slide on ambiguity as well, if you have bidirectional relationships. So I would try to avoid them like the plague. Try to avoid them. If you really have to do this, let's just go here. If you really have to, you can use a cross filter function in DAX to change how the filter can flow. So even though the filter is going from product to sales order, so only from here to here, you can, if you wanted to, do a calculation in DAX to say, what's the number of products that we sold on the May 5th with the sales? You could do cross-filter in a calculate statement, change for just that statement, change the direction in which the filter can flow, and then get your answer. That's a way to do it. Avoid bidirectional relationships in general, because they can lead to very weird results, bad performance, and business users screaming at your desk because the results are incorrect. Don't do that. Why? It's because it can easily lead to very weird things. For example, here's what we call an ambiguous data model. So here we can see that, let me just think about this one. What do we do? So here we have data flowing from, we have filters flowing from internet sales to product and from product to internet sales. So now if I wanted to do, to filter, let's say, on a certain date, on a certain year, what happens? Well, you will probably be interested in saying, hey, for this date, what did we sell, internet sales, and what did we have in inventory, right? You will probably want to know that. Fine, great business question. However, because of the fact that between internet sales and product, there's a bidirectional relationship, the moment you said, let's say, May 1st as the date, your internet sales will be filtered. You will only show the number sales that you did on that date. Great, that's what you expect. However, because of that happening, the list of products will also be filtered to just the products that were sold on that date. That's not what you expected, because now product is filtered, look at how product will also filter inventory here. Because now you reduce the number of products. As a result, that filter is happily flowing towards product inventory. Now your inventory answer is not how many products did we have in stock. No. Your inventory answer is now how many products did we have in stock on this date that we sold on the same date. That is probably not what your business user was after here. That's why you can easily shoot yourself in the foot if you build these kind of relationships with bidirectional. You get an ambiguous data model, and you will end up in weird situations where your business user goes like, but the inventory is off for this date. Yes, that's because that filter flows all the way around and then also filters inventory where you didn't expect that to happen. So this is an ambiguous data model, something you should avoid. And then you can use cross filter to get rid of it or activate certain filter paths in certain situations. So you can do, for example, you can say, hey, for my calculation here, for example, I have in the same chart have multiple calculations. So the light blue one is the default one, and then I can write a calculation using cross filter to deactivate one of the other paths to make sure that I can actually forcefully get that calculation and be sure that that's actually the result that I'm looking for. So just avoid creating this loop of relationships. The moment you see a loop of relationships, by the way, that you go from one table to the other, to the other, to the other, to arrive at the same one, red flag. That it's not a bad thing. It can be good. But if there's a BiDi in there, so if there's something that allows you to go all the way around and keep going in a circle with the filter that can flow from this to this to this to this and then get back to here, that's a real problem. That's where you have an ambiguous data model. That's a problem. You don't want to do that. Never, ever. Or in the other example that I had, is where one table, right, the inventory. So let me just go back one slide. One slide, two slides, how many slides? I don't know. This one. In this example, we have inventory over here on the right. Here, we start with date to filter, right? We filter from date to inventory. Great. We expect that to be done. And now, because date filters internet sales, which filters product, and product filters inventory, now suddenly you have two filters on inventory, which we didn't expect. So that's another way where this circle will potentially lead to weird results. So I hope that helps on direction.
I have a question on that.
Yep.
So does it mean if you filter on a date, that internet sale, that automatically leads to product and product inventory. It means the amount is getting filtered like 2 more time, which we don't want, right? And it is definitely giving you like a lesser kind of a result
Or
because it is
inventory,
more filtered.
yes.
For the I believe even for the sales, because now the sales is not just on a date, but in fact it's on a product as well as
No,
inventory.
no,
It's
no, no.
more filtered out.
No, if you start with date,
Mhm.
you filter out sales, right? So let's say you put a filter on date to say only in April 2022.
Mhm.
That will filter the amount of dollars that you made in the sales, right? But not all products were sold in that month, probably. As a result, it will filter the product table. So the sales amount information will be correct, but it will filter the product table. And as a result, your inventory information will not be correct because that now gets the filter that was propagated from sales to product to inventory. Your sales number will still be correct because it is the sales that filters the product, not the other way around. Now, if you start from product, this is not as big of a deal because if you just say, hey, I'm only interested in brew products, it can filter internet sales, it can filter inventory, but it can never filter date. So in this case, from that direction, it's okay because it won't flow around and then filter inventory, which wasn't expected. But your sales numbers should still be correct.
So when you say sales number would still be correct, are you considering like in a visual, there are columns with respect to like date, sales, as well as product and product inventory?
Yes.
And then the product and product inventory will not give a correct result. Just the sale would be correct in respect to the date.
In respect to the date, yes.
Okay. Okay. And when you say the loop, how about if the bidirectional is on a customer instead of product? So the customer is not making any loop in this current diagram. The customer is just tied up with the internet sales.
Right.
So in those scenarios, would it be okay to have like a bidirectional, filter?
Well, depends, right? Let's forget about product and product inventory. They don't exist, right? For a second, right? So they don't exist on this thing. So these are gone, right? Fine. So we do this, but then we change this to a BiDi. So let's see, this goes to BiDi. That's what you're saying?
Yes. Yeah.
Okay. So in this case, if you say, I'm only interested in the internet sales for May, then you will only see the internet sales for customers that bought a product in May. So your list of customers will also be filtered.
Okay.
So if, for example, in the same visual, you not only ask for the sales in May, but also ask for the number of customers, that number of customers will only reflect customers that actually bought something in May. Not all the other customers that did buy something in April. They will not be shown. They will not be returned. So let's say you have 100 customers, but not every customer bought in May, only 40 of them. If you make a calculation that says, give me the number of customers, it should return 100. But if then with this data model, with this BiDi, you set the date to be May, then the result of the number of customers will be 40. Because that's the number of customers that actually bought something in May. Because as a result, date filters internet sales and internet sales filters customer. Does that make sense? Can you see how that filter flows?
Got it. Internet sales filter customer, but also then the customer would filter internet sales. I'm not getting the point where sales would not reduce, it's just a customer number which is getting, incorrect.
Yes, because you already filtered sales, right?
Okay. So it would be just one-time filter. And then
yes,
internet.
It doesn't go back and forth because there's nothing to filter, right? Because let's say you have like yourself, Cecilia, and me as customers, right? You bought products. Only you bought a product in May. So we set it to May. Then you bought something for $50. So the total sales amount is 50, and it will say number of customers 1, you. Now that filter of just you can be propagated to internet sales, but it won't change the number because the 50 is still what you spent, right?
Okay. Okay.
It won't change the number again. It has already changed because the date filter.
Okay. Yes.
So but this is very tricky, by the way. It's not easy. And of course,
Yeah.
it's a very simple example. And in real life, these examples are never that simple. But when you see these kind of things, when you see weird results, look at BiDi, look at loops, and go. Sometimes it just helps to make a screenshot and take colored arrows to go paint out how the filter context, as we call it, how filters can flow through your data model. And once you see with the same color, you end up on a fact table that you didn't expect to be filtered, that's where you go like, what? That's where you need to be careful. That's exactly the example that I have here, right? Where inventory is actually filtered, where we didn't start with filtering inventory, or we didn't expect it to be filtered by something else than just date. It's all about what's the business question, right? Sometimes this can be exactly what you wanted, but most of the times it's not.
So the use case, what would be the use case for bidirectional to be on sale? Can we say we need a bidirectional if we like to see only the product where the sales is greater than $100, for example? Is it would it be the case for where the sales is filtering now the product?
Yes.
We would like to show. Yeah.
Yes, in that case, you could still answer that with only one direction. But assuming you also want to filter on product category to sales, if your business users also want to do that in certain cases, then yes, you need a BiDi.
So if we want to filter the sales on the amount, so we are just interested in everything above $100, for example.
Right.
So in that case, now the sales is filtering the product. It's
Yes.
like the other way around, right?
Yes.
Oh, got it.
Yeah. Cool. I have to wrap up, by the way. We're 7 minutes over and my manager is waiting outside.
All right, then. Thank you so much for this, for your time and for presenting and discuss this topic. And thank you, everybody. And we will post the recording very soon. And you are always welcome back to this group, Jay. I love to have you here. Thank you so much.
You know, just let me know whenever you need me. There's way more that we could talk about for data modeling. So maybe we should just do a follow-up at some point.
Yes.
I'm happy to come back. I'll let you just let me know whenever you need me. Okay.
Super. Thank you so
Okay.
much.
Thanks all.
Bye-bye.
Bye-bye.